All right, so this is section 9.2. Yeah, it is 9.2, right? Yeah, 9.2, part C. All right, and we're just going to call it the nth term test for divergence. Should be a relatively quick lesson, okay? I'm going to write down a couple of theorems. They're not too long, but let me write them down, then we'll talk about them. So theorem 9.8, this is called the limit of the nth term of a convergent series. Of a convergent series. And it says if the series, the sum as n goes from, actually they're not going to give us where to where, just the sum of the series a sub n converges then the sequence converges to 0. So sequence a sub n converges to 0. Notice this is a conditional statement. If the series converges, then the sequence converges to 0. Okay? And then let me write the other one, then we'll kind of talk about it, things that you shouldn't assume. Theorem 9.9. This is the nth term test for divergence. It says if a sequence, and they're going to call it a sub n, does not converge to 0, then the series diverges. These two theorems are often misused, okay? And it's kind of easy to understand why, because a lot of times we see an if-then statement, so then we assume that the converse must be true then, right? But let me talk about theorem 9.8 first, okay? Theorem 9.8 says if the series converges, then the sequence converges to 0. Okay, remember, series means you're adding everything up, right? It has the sigma notation. The sequence means it's just like an expression and you can write out a couple of terms, right? So if the series converges, notice they don't tell us converges to what. They're just saying it converges, so to some number. Okay, so if the series converges, then the sequence converges to 0. It is not true that if the sequence converges to 0, then it implies that the series converges. Okay? So, in other words, and we'll see this later, but to give you an example, think of the sequence 1 over n, okay? If a sub n was 1 over n, so let me give this to you here. If a sub n is 1 over n, what does that converge to? In other words, what's the limit for this thing? If I take the limit as n approaches infinity of a sub n, that would be a 0, right? If I do limit as n approaches infinity of a sub n, that's 0. But I can guarantee you that if this converges to 0, then the sum of this, that diverges. I know that diverges because that's actually called, well, we'll talk about that later, but this is a specific type of series. Okay? but I know that that series diverges. Okay? So if if a sequence converges to 0, it doesn't mean that the series will converge. Okay? So for theorem 9.8, make sure you don't use it backwards. Okay? Don't confuse it by using it backwards. So it only tells you that if the series converges, then the sequence will converge to 0. Okay, let's listen up, guys. Just give me those 10 minutes. And then theorem 9.9, it says if a sequence does not converge to 0, then the series diverges. A lot of times people say, oh, so if it doesn't converge to 0, then it diverges. Well, then what happens if it does converge to 0? Well, people will say, oh, well, then that must mean that it converges then, right? But that's not true. The theorem doesn't state that. The theorem only tells you that if you take the sequence and it doesn't converge to 0, then the series itself will diverge. Okay, and I know you're thinking, well, I don't see what you're talking about. We'll do some examples right now. But just be careful not to misinterpret 9.9. 9.9 is strictly a divergence test. It doesn't tell you if it converges. It only tells you this is what will happen in order for it to diverge. Okay, so if the sequence doesn't go to 0 when you take its limit, then the series diverges. If the sequence does go to 0, then I have no idea what happens. Okay, the sequence that theorem doesn't tell me what occurs. So here we go. Here's the examples. There's 3 small examples, and then we'll be done. I think this is example number 5. Am I right on that? No, what is it? Oh, it is 5. Okay. So test for divergence. Okay, we're going to test for divergence. So part A. Here is a series 2 to the n. Okay? So we're going to do the nth term test for divergence. Okay? The way you do it is you take the sequence. Remember, the sequence is the thing inside of the parenthesis. And you're going to take the limit of it as n approaches infinity. Well, what does that equal to? It's infinity, right? Now, look at my theorem 9.9. It says, if the sequence does not converge to 0. Did that go to 0? No. So then what? Then the series diverges. So I'm going to say, so this series diverges. And that's it. That's the test. Okay, so that series diverges because the sequence did not go to 0. Yeah, you're just checking to see what occurs with that sequence. So here's another one. So the sum as n goes from 1 to infinity of n factorial over 2n factorial plus 1. So I'm going to take the limit as n approaches infinity of n factorial over 2n factorial plus 1. What's my limit for that? I think someone said it. What was it? A half. Which, is that 0? No, right? That's not 0. So then what can I say? The series diverges. Oops, all right, change color here. So the series n goes from 1 to infinity of n factorial over 2n factorial plus 1 diverges. Okay, this is using the nth term test for divergence. That's my whole goal, is to try to show you by using that test that this thing diverges. Last one. So pretty easy, right? This is actually one of the easiest tests to use. They do get more complicated sometimes. So, all right. So the limit as n goes to infinity of 1 over n equals 0. Well, the definition says if the sequence does not converge to 0, then the series diverges. What if it does converge to 0? That's exactly what I told you not to do, right? But that's what a lot of people do. We don't know. We don't know whether it converges or diverges. Look at the theorem. It specifically states that if it doesn't go to 0, it diverges. Does it say anything about if this happens, then it will converge? No. This theorem is very specific. So that's why I told you guys, sometimes in our brain, we say, well, it didn't do what it said it shouldn't do, so then maybe if it did something else, then the opposite is true. The top one just says that if the series converges, then the sequence converges to 0. Right? That's a whole different thing. Yeah. So, like I said, Theorem 9.8 and 9.9 are so commonly misinterpreted with what happens if the theorem doesn't hold true. Well, then people will say, well, then maybe the contrapositive is true. Right? So our brain does that naturally. So I'm telling you guys, be careful. The nth term test for divergence only tells you one specific thing. If the limit is not 0, then the series diverges. If the limit is 0, then we don't know yet. Okay? So for this one, we're just going to say, I'll put right here, since the limit as n goes to infinity of 1 over n equals 0, then we don't know if the series as n goes from 1 to infinity of 1 over n converges or diverges. So we have no idea. Okay?
Even if it doesn't go 0, they can still diverge?
Yeah, this one actually does diverge. Yeah, this series is a divergent series. So, all right. So I'm going to give you guys a homework, and then that'll be it for today. All right, so there's the homework for today.